Hi everyone. In my last two videos, I was talking a lot about like how much is the insurance that term insurance that one would require, and what is the kind of retirement planning that one should look at. And I was briefly touching upon these terms like safe withdrawal rate. So in few of the comments, somebody was actually asking for explaining safe withdrawal rate with its full mathematics behind. I've went through a few of the theories and few of the like thumb rules that goes behind safe withdrawal rate. And what I found is like everywhere it is kind of explained that a safe withdrawal rate is something between 3 to 4 percentage, and that's something like somebody can assume safe. So let's take a moment and pause there, and let's actually make a framework what is safe withdrawal rate. So as people can actually guess, safe withdrawal rate is a percentage amount that we can withdraw from a corpus uh, in the start of every year, so that corpus, the present value of that corpus doesn't decay, as well as that withdrawal that we withdraw every year is enough to meet our expenses. So theoretically, we can say, suppose somebody has an X amount and he has assumed this is the safe withdrawal rate, and he is withdrawing this amount from his corpus and then investing that corpus for each year, then he should be able to sustain the value of the corpus till infinity, or we can say till the time he is kind of able to generate the average annual rate of return that he can generate. So in this video, let's go through what is safe withdrawal rate, why is it important in retirement planning, and what is a practical safe withdrawal rate. First we'll go through that theory, and then I will kind of touch upon what are the practical implications of like whether we should take a theoretical value or whether we should take a much conservative value. Okay, so let me go to a spreadsheet. So this is the spreadsheet I prepared. So this spreadsheet kind of considers 45 years, okay, like this is numbered here, 45 years from today. And for the sake of simplicity, I have assumed the corpus amount is 100 rupees. I mean, I've assumed it as 100 rupees because everything will come in percentage terms. And this column gives the amount of the withdrawal every year. I mean, if you see this amount and we are multiplying it with this safe withdrawal rate, okay? Now this is the remaining amount, nothing but the start of the year amount from where the person withdraw some money, and that this is the remaining amount, and this remaining amount is invested throughout the year. So suppose we are assuming a 12 percentage of return as a CAGR. So this is the amount that accumulates at the end of the year. Then the next year it will be the same amount, right? And the same amount again getting withdrawn at the same rate of safe withdrawal rate. I mean, this calculation is done for 45 years. And with this amount of 45 years of calculation, we should be like kind of able to say how much would be the safe withdrawal rate. And these two line items, there's a PV of the corpus and P of the expenses, is nothing but present value of the corpus, that is the value of the corpus at the end of 45 years discounted as of today. Okay, and this PV of expenses is the expenses, amount of expenses you can withdraw from the start of every year, that's at 45th year, and the present value as of today. Okay, so if you see here, like discounting I've done here is this 1.07, where we are assuming 7% as an inflation, and this is discounted for 45 years. And when you come to PV of expenses, this is discounted only for 44 years, because we are withdrawing this amount at the start of the 45th year. So it's the duration is only 44 years. Okay, so I mean, all the formulas are put in place. We just need to change the rate given here, so that theoretically we can kind of put in numbers and see how much is a safe withdrawal rate. So what are the two assumptions we are doing here is the rate of return that we are able to generate every year is 12 percentage, and we have assumed a inflation, lifestyle inflation, or like not exactly lifestyle inflation. It's more of like the inflation in the general economy. I mean, one more point to note is like after retirement, if you are not generating any extra income, you cannot actually go for a lifestyle inflation, right? You would have to keep up with the lifestyle that you are expected to pursue at the moment you retire, right? So we have put a 5 percentage here. So when you are putting 5 percentage here at a rate of return 12 percentage annually, the PV of the corpus comes out to be 77, whereas we started with 100 rupees, right? So basically, this indicates that there is a decay of mm, the corpus, right? So theoretically, it will not reach infinity. At some point in time, it will come to be zero. And if you look at the PV of the expenses, since the corpus is decaying, PV of the expenses also decayed, right? Here, the PV of expense was 5 at the start, right? Now it became 3.9. Now let's put 4 percentage here. So when you put 4 percentage here, yeah, PV of the corpus is more than 100. PV of the expenses is also more than 4. Now PV of the expenses more than 4. Okay. Now, like we understood, this safe withdrawal rate theoretical in this case is a number between 4 and 5, right? Now let's go to the math behind it and kind of see how we actually like arrive at this number. So we are actually just solving a linear algebraic problem here. That is, we have put 100 rupees in the start, and the start itself, like we have withdrawn some amount at a rate of r. So we are multiplying it by 1 minus r, and then we are again multiplying it by the CAGR at which we can generate the return. So we have assumed it as 12 percentage in this case, and the amount after generating this return, the total amount should be at least meet the inflation, right? So inflation is 7 percentage. So basically 100 into 1.07, that's 107, right? So we just need to solve for r in this equation, and when you solve for r in this equation, it comes out to be 4.46 percentage. So if you see here, your safe withdrawal rate is nothing but a function of the assumed inflation and the rate of return you can generate. So in this case, the assumed inflation is 7 percentage, and the rate of return you can generate is 12 percentage, and it comes out to be 4.46 percentage. Now let's put that number here, like to practically see uh, how much correct it is. So if you're putting 4.46 percentage here, see your PV of corpus even at the end of the 45th year in today's term is just more than 100, and your PV of the expenses at the start of the 45th year is almost very equal to or just more than the current uh, expenses, right, which is 4.46 rupees. So this way, this corpus can actually sustain till infinity given uh, your withdrawal rate doesn't increase, and you are able to continue to generate a return of 12 percentage annually. Now let's go back here and see what are the what is the practical implication of this, right? So when people actually say, hey, your safe withdrawal rate is something between 3 to 4 percentage, or it's like 4.6 percentage, or whatever it is, I have seen people taking it blindly. Hey, like if we have this much corpus, and if it is able to meet my expenses by assuming this safe withdrawal rate of like 4.6 or 4 percentage, I am good. Now let's come back to this equation, and this is the key here. the expected annual rate of return is 12%. It is assumed 12% here. And assumed inflation is 7%. Let's not touch the inflation part. Let's assume it as 7 or 8%, whatever it is. But this expected annual rate of return, 12%, we are quite sure that we will not be able to generate this kind of a return by any kind of a fixed income instrument, right? We would have to invest in equity, mutual fund, all those things. So now, if you actually take the fluctuations of these equity returns or mutual fund returns, we know that this is not never a uniform return, right? So it can differ. So again, let's come back to this calculation. So it will not be like every year you are able to kind of generate 12% of return. So there could be a situation, suppose somebody is retiring or somebody is generating that corpus uh, like at the end of like what, after 20 years. If somebody is able to generate this corpus after 20 years, and suppose he stopped working or generating income at the end of 20 years, and at that time this equity is giving some low return, or it is at kind of an all-time low or something, then that would impact his corpus and withdrawal a lot, right? So what I am trying to put in is your equity returns is never a uniform thing. So this calculation will go for a toss if your equity returns, suppose like actually you are getting a 13, even 13 percentage of an equity return for a 50 years term, but for initial 4 5 years you got almost 7% of return, then this calculation will go for a toss or totally, because you're actually like, even though it's not generating enough return, because we are talking about a case you're generating a return of a 7% and you're actually like your expenses, you are withdrawing something from that corpus, and rest there is an inflation of 7%, then we all know, right? Like if you are generating something at 7% and there's an inflation of 7%, your present value is not even increasing. Then forget the case where you are withdrawing something and then thinking about it. So what I'm trying to put in is the rule of this calculation, that 1 minus whatever the inflation percentage divided by whatever the total return percentage that you can generate, this 4.46 is a theoretical case. So for your practical situations, you would have to uh, again kind of subtract at least 1%. I mean, I am coming to this 1% number after considering many of many of these kind of cases where I have taken various uh, paths of returns based on the past equity what Nifty 50 has given. Okay, so based on that, like you have to at least you have to subtract a 1%. So it will, this 4.46 percentage will come to like 3.46, right? So we can kind of say that safe withdrawal rate, if you are able to get an annual rate of return of 12% averaged out over 50 60 years, is between 3 to 3.5. Now, again, it differs based on person to person, based on what is his risk appetite. Somebody who is investing only in FDs or fixed income things, he will never be able to kind of come at this kind of a safe withdrawal rate. Suppose FD would be giving a 7% of rate of return, and if he's taking some money out of that and rest is kept with an inflation, I mean, he's able to generate 7%, and then again there is a economic inflation of 7%. Then at the end of the day, his corpus is decaying and it will not sustain much. So with this video, we can kind of conclude that your safe withdrawal rate is very much a function of what kind of a return you can generate, and being said that it is affected by uh, economic cycles as well, right? So my urge to everybody is, whenever you consider safe withdrawal rate, you look at what is the expected annual rate of return you are able to generate over the past 20 30 years, and based on that you calculate, rather than going by some thumb rule of 3%, 4%. Somebody would say 5%, right? So that's not the way you should go for it. So with this video, you should be able to calculate your own safe withdrawal rate and enjoy your retirement. Thanks, guys.